Okay, here's another linear equations video, and this one is on the exceptions in y equals ax plus b. I'm going to explain what I mean. So in our last video, we learned about how a straight line on a Cartesian plane could be defined by an equation y equals ax plus b, where a is the slope and b is the y-intercept. This video is going to focus on what happens if there's an exception there, like what if it doesn't quite look like y equals ax plus b. And yes, there are a few cases where that's going to happen. And we're going to look at those exceptions over the next couple of minutes. So first of all, what if I don't see a number where I'm expecting to see slope or y-intercept? What do I do then? Now we'll start off with slope. So what if my equation looks like y equals negative x plus 2 or y equals x minus 8? I don't have that number out front of x that represents slope where I'm expecting it to be. Well, the explanation here is actually really easy. When you don't have a number in front of a variable, it's like there's an invisible 1 there. So in the y equals x minus 8 example, out front of that x, there's an invisible 1. So the slope of that line would be 1. And in the y equals negative x plus 2 example, because it's negative x, there's an invisible negative 1 out front, meaning the slope of that line is just negative 1. So now what happens if I have a line that doesn't show a b value in the equation, like y equals 0.5x or y equals negative 3x? What do I do then? All this means when the b value is completely missing is that the line passes through the origin. The b value is actually 0 there. So I could rewrite the first equation, y equals 0.5x plus 0, and the second equation could be rewritten as y equals negative 3x plus 0. So these two lines actually do have y-intercepts. It's just that because we're, kind of lazy by nature, if the y-intercept is 0, we don't bother writing it. So it's understood, though, if a line doesn't have a y-intercept in its equation, like one of these two, that those lines actually do pass through the origin. They do have a y-intercept. It's just 0. Now, it is possible also that an equation is missing the x or the y value in it. Something like y equals 10 or x equals negative 8. And these special cases are used to represent perfectly horizontal or vertical lines. Now let's look at y equals 10 first. If I got an equation that just said y equals 10, what I'd be looking at here is a line, and all I know about it is that it passes through a y value of 10. It's perfectly horizontal. And if you think about it, the definition of the line being y equals 10 is actually pretty appropriate here. The x values range from negative infinity to positive infinity. So x could be anything. And the only thing I need to define my line is that I know the y value is 10. And it's always 10. It never goes up or down from there. Hence the equation y equals 10. Now a similar rule applies to x equals negative 8. If we look at the line through x equals negative 8, the y values vary from negative infinity to positive infinity. But the x values never move left or right from negative 8. So while y could be anything, on this line, x is always negative 8. And the equation, x equals negative 8, makes perfect sense. Now, one last thing I need to mention here is that sometimes you might get an equation that doesn't quite look like y equals ax plus b. It's a complete equation, but the numbers don't seem to be in the right place. So it might look like this or this. And anytime we see either of these equations or anything that looks like them come up in this course, we're going to stop right there in whatever question we're working on and isolate the y variable. Because when we isolate y, the equation is going to look like y equals ax plus b. Now remember, isolate just means to get something all by itself. So in each of these equations, I'm going to isolate that y variable and see if the equation makes more sense once I do that. And now that it's done, I can see the slope and the y-intercept of each line, meaning the definition of the line is a lot more clear now that my work is done. So now check out a couple of examples on exceptions in y equals ax plus b and how they might pop up in test questions.